And it is a pleasure to introduce Professor Maria Chiara Carrozza. She is a professor of biomedical engineering and biorobotics at the University of Milano Bicocca, former president of the National Research Council of Italy, and she served as a chair of the European Science Advisors Forum. She was a minister of the Italian government of Education, University and Research, and the scientific director of the Institute of Dognocchi in Italy, because several parts of the institute. Thank you very much for your presentation, and that is, I think, a very important also contribution for our meeting. Please.
Good morning, thank you very much. And so my talk will be on design and responsibility, and I suggest this way of presenting it, the triple R approach to robotics and AI in life sciences. So it's on robotics and AI and how they are related to life sciences. So what about our consciousness? I know that yesterday Marcello talked about consciousness and explained his approach to experimental science and application in life science, and with some also clinical trials and clinical application problems. So I am, of course, wondering and investigating on what is consciousness, but I am more interested in understanding how our consciousness is developing, and how the use and the education and training and the use of, for example, generative AI is implicating a change in the development of consciousness or in the development of cognitive abilities, especially in children at school. So generative AI is somehow evident in many applications, but in other applications it is hidden in the content, in the interaction, in the involvement and engagement of the user. So when we are dealing with children in training and in education, we have to understand how their ability of developing identity, consciousness, cognitive abilities, understanding and reasoning is affected by this use, and how we want to investigate on the effect on their knowledge. So I wrote a book on how the knowledge is important in the future and will be important. And knowledge to me is important for the development of our cognitive abilities and our understanding of the world. So this is my point. So I would like to discuss this with you if you are interested. So, and the second point is that experiments and science-based evidence, so our work, when we have a model of the world, of a theory, we have to develop an experiment to validate or to understanding if our model is correct or is representing the real world. Without these experiments, our theory is not valuable. So we need experiments, and today we need more and more experiments. So we are in the age of experiments, mostly because some content, and the content that is online, for example, so pictures, photographs, news, histories, and more, is generated by AI. So when content is generated by AI, some artificial content, experiments are even more important than before, because everything we are entering into by means of the media, for example, or by means of history books or articles or papers, we have to understand how the evidence is proved and if the experimental method has been applied. So experimental methods today is fundamental for our future, and is more fundamental than before in life science, because we are dealing with biological beings, with human beings, and so we have this responsibility of explaining that if we want to move forward our knowledge and the application of AI or robotics, of technology, we need experiments. Without experiments, we cannot go forward. We can only speculate, okay? So, understanding the near future, I put on this slide some few points on what is happening in the near future. First of all, generative AI in education. So the application of generative AI in the education and personalized virtual tutors, that means agents, okay? Agents means something much more, I think, controversial, but also productive, but even powerful than responding to a prompt or reacting to a question. Agent is somebody which is proactive, some virtual body, some human body, some, we don't know, agent. Agent is performing something and so is guiding the education. So we are putting our children, the new generations, in front of agents, which are artificial agent or agent programmed to do something, and we have to understand how the effect of these agents will be in education and in their knowledge and intellectual abilities. Then we will have, and we have today, collaborative robots in industry. That means that in the factory, there is a new wave of automation, which is much more powerful than in the past. For example, in automotive application, we already have robots and workers are outside of the working space, okay? So there are robots mounting, assembling, manipulating things in the mass production line, and workers are out of this space. So in the future, so in the present, many projects are bringing again workers and robots together, sharing the workspace. This is the present challenge, to put together robots and human beings in the factory for the moment, but it is clear that in the future will be in the public environment. So collaborative robots are the most important today. And this implies many things in terms of technology, and I will try to enter into that. So we need new ethical standards, but we need maybe ethical standards agent, something much more proactive than before, because the challenges are new, the methodologies are new, so the problems is the same, but there are new ways of approaching the problem. So we need new ways of approaching the ethical issues. So in the distant future, more distant, not so distant, we will have AI and robotics in healthcare. Today we have service robots in hospitals. We have robots that we call surgical robots, but we will have more and more robots close to the patient, so not performing only surgical intervention or carrying drugs or things in the hospital, but we will have these cobots, so collaborative approach. So that's in rehabilitation engineering, for example, we already have the robot, the patient, and the therapist together. So it's the robot is mediating the therapy. Okay. So we will see the methodology, then the approach that we will have in future in this triangle, the trilogue: robot, patient, therapist, or nurse. Immersive education in technology. So immersive education is something which is interesting. So nobody now is speaking about metaverse and thing and virtual environment, because we are all concentrated on robots in my area. Okay, I am speaking for my area. But immersive education is something which is also very critical, because immersive environment, especially for children, are mixing the virtual with the real world. And this implies many things from the point of view of cognitive abilities and development of the sense of the real world. And we will have AI-driven agents in educational governance. For example, monitoring patients, monitoring children, monitoring pupils, evaluating essays, providing exercises and contents driven by the performance. So according to the key performance indicator of the evolution of the competence and knowledge, and this will imply something which will adapt. So in principle, empower the ability of the subject, but we must follow this evolution and understand if it is for the good or not. Okay, that means the final outcome, which are the cognitive abilities of children and their balance. Okay, so the future of humanoid robotics. So humanoid robots are the eternal promise. So I am fond of Isaac Asimov, of course, and he presented a world in fiction with the robot interacting with human beings, and it's very interesting. I will, in the conclusion, I will propose to you to reread a book which is, I think, important for our present and future. So these are the eternal promise with many drawbacks, many, I don't know how to say, but many problems and limitations of technology preventing the introduction of humanoid robots in real life. But now there are new trends. First of all, Hyundai, working with Boston Dynamics, they are developing a production-ready humanoid robot for developing in the factory the new vehicle. Okay, so it is a testing. So in the past, when I was studying, I was assistant professor when I was young, we were used to say that humanoid were not useful in the factory because it's much better to develop a robot which is designed for mass production, not repeating the same limitation of the human body and human condition. Today, all big factories are developing humanoid robots in the factory. So we have to start to understand why. We must wonder why they are using humanoid robots in the factory. Maybe to replace workers for aging problem, for demographic problem, maybe to replace workers for safety, maybe to use the same environment and to put humanoid workers instead of human beings. So this is philosophically something which is really new and interesting to my opinion. So there will be advanced AI integration, and we will speak about that. I go fast because I don't have much time. And then there is the Tesla Optimus. Tesla is coming from the Tesla vehicle, applying autonomous drive and self-driving car software and systems based on sensory feedbacks and using similar technology. And the most important technology is the battery. So Optimus is built around the battery because the battery, so the energy source, is the most important part in robotics, the most relevant limitation, together with the interaction with the human being and safety and security of the human being. But we will stay on this later, but they have ambition of massive scale. What I think, this is only my opinion, my humble opinion, is that they want to sell one robot for, at least one robot for every family in the world. So instead of buying a vehicle, a car, we will buy a robot, at least one for our house, for our personal use. So it's replacing automotive because the automotive model is failing. Okay, in Europe, we know in Germany is going down, and Italy is twinned with Germany, so if Germany is going down, also Italy is going down, and so the production of industrial robots is going up only for China, because China is guiding the evolution and installation of industrial robots, but Germany and Italy is not going well. And then there is the Amazon approach, completely different in principle, using all technology which is available today. It's a dream for roboticists because we worked on tactile sensing, artificial hand, mobile application for mobility of robots, of platforms. Amazon collected all the main results from research and made what we call hyperscale robotic deployment. The highest numbers of robots are in the Amazon approach, which was not based on humanoid robot, but on the in the extreme words to amplify automation and effectiveness. So it is based on productivity, which is a dream today, because we know that productivity is the problem of today. So everything is done for productivity increase, okay? So But there is an emergent field which is much more complicated, which is wearable robotics. This is a video, I don't know if it works, in Santiago del Chile, which is a company for developing a wearable exoskeleton. So not only in Europe or North America or so. It's we have to see all over the world. Okay, because innovation now, today, is everywhere, and we have to understand where it is deploying. And the future, maybe, or the present future, or the present vision for the future is based on social robotics. So robotics is used in children and in development age for autism, for example, for assisting children delivering therapy based on social robots. So they were designed and experimented with for autism and for other cognitive disability, for taking company, establishing game theory and using gaming and also interacting, engaging children. So it is clear to me that in the future the idea is to use with all children, not only with children with autism. Of course, there are therapy robots and there are entertaining robots, but in the middle we have education robots, okay? So in the future we could be engaged with education robots. And there are also other projects and with humanoid robots like waiters or doing housekeeping and with human being appearance. This is a Norwegian and American project. And there were also old projects, not successful, but now reinvented, like the Aibo dog, the Sony dog, which was not successful because it appeared early, too early for the market, but today maybe it will be reinvented, and there are other entertainment and education robots and also robots for delivering care to elderly people in Japan. So we have many examples, but the technology today is developing new applications. So very fast. First of all, one of the breakthrough will be to introduce the physical world into robotics. That means in language model to introduce new languages like not only images but also tactile interaction. So from the neuroscientific point of view, touch and hearing are very similar to vision, okay? So if you introduce, why using only vision and not using tactile sensing and touch? Because touch is fundamental to interact with the environment. So if we want to develop better robots, able to generalize objects, to generalize that this is a glass, that means a robot doesn't know that this is a glass. I can plan the reaching and grasping phase for a robot, but with this glass. But the robot, for the moment, is not able to understand that maybe another glass is similar to this, or a mug or other objects are the same and usable for drinking. So by developing that kind of models, we can generalize all kind of objects that can be used for drinking, can be reachable and manageable by robotic hands to bring water to the subject, okay? So this is an example because reaching an object in the space, grasping the object, manipulating it, and bringing the object to the mouth is something which is fundamental for robotics. Still a challenge, very important challenge. So there will be maybe physical laws and constraints in language model, but there will be more models based on feedback. So trying to generalize from vision to touch and to hearing, for example. Then there will be future brain-computer interface, one of the larger markets that is expected in the future. So that is to understanding the state of mind. So it's, I think that the brain-to-computer interface, it's a sort of bridge between mind and brain, okay? So trying to understanding from the brain signals the mind state of the subject, which is fundamental. It could be fundamental for many, many applications and for improving the co-robotics, so the cohabitation between a robot and the subject. Of course, there are many applications in the health sciences, in neurodegenerative diseases, and this brain-to-computer interface, for example, are used like pacemaker in the heart, so to modulate control signals and similar. So these are very important applications, but there are a lot of studies for investigating on the state of mind. This is the emotion, the state of the person interacting with the robot. So if we want AI in the care, so AI in the care means image-based, biomarkers. Biomarkers are like brain-to-machine interface. Biomarkers means that we have signals for understanding a disease which is coming or preventing the evolution of a disease, or monitoring the evolution of a chronic state. So biomarkers for biomedical engineer are the objective, to develop from what we can measure signals and that are presenting to us that some state is changing and that we have to make a better diagnosis or to deep our knowledge about the state of the physiology and development of disease. So if we want this, we need clinical trials. So to me, it is not ethical not to develop clinical trials to test the technology in patients. If we slow down this process because we are not able to organize our system, that we are not finding solutions that we have and we are not applying the solution. So there are three parts. The context, okay? So the problem of compliance. If I have to be compliant to something, I react to some rules. The rules are based on previous knowledge, but innovation is something which is destroying previous rules and previous methodology. So we don't have to rely only on compliance to rules. We must go beyond this and go forward, because innovation and compliance are not really compatible for making experiments. We have to deal with another model for supporting innovation. And so this responsibility and ownership and the ethical accountability and also the impact, the social impact. So to add to the sustainability equation, the social impact of innovation, because must count, even if the step for investing in research is very expensive. Somehow in the final equation, we have the social impact. We can prove that this investment is affordable, because at the end, the good, the benefit for the patients is much more than the investment. Finally, we have a problem that I want to present to you in conclusion. First of all, we are speaking about embodied AI, because my colleague in AI, they say embodied AI. So a robot is a sort of embodied AI. They give a body to their AI system. We roboticists, we say AI is providing better controllability to the robot. Okay, so it is maybe in the integration of the AI with robot, which counts, but embodied AI means that the driver will be to the cognitive engagement, not to the physical support. To me, I am a bioroboticist, I develop exoskeleton. The most important point is that the exoskeleton supports the walking of a disabled person. Maybe for this embodied AI, it's much more complicated. So embodiment is something which is the word of today, and I think in the future we will speak about embodiment much more than today. And enabling innovation is fundamental. I don't enter in detail, but we need clinical trials. We need to accelerate innovation, especially in Europe, for example, but not give the innovation only to some specific countries, okay? So it's important that everywhere there is a competitive race to innovation, and we need early experiments and rules for early experiments. So this point is related to the fact that today science is not possible with competitive research, and this is done with technology. So technology and research are strictly connected. If we don't have technology, we don't have science, and we don't have research. So the acceleration and the boundaries between technology and research, for example, AI was object of research, now is the means for doing research, and is becoming technology. So this is a continuous cycle. So I propose to have research integrity, which is one point fundamental for institution. I was president of the National Research Council, so I have many issues related to research integrity. As many researchers you have, as many problems of research integrity you have. Research ethics, of course, and we have to develop new models for research ethics, and research security. Okay, if I have a robot here in this environment, and somebody hack my voice and mimic my voice and control my robot, can cause harm to you. So research security is fundamental, and also security in robots is the first priority. No security, no robots. Okay. So I propose to study this conceptual scheme. I am at the very beginning, but I would like to discuss with you. And I finish with the first book of the Foundation by Isaac Asimov. He said, one of the heroes of this novel suggests that violence is the last refugee of the incompetent. Okay, so I leave you with this book, which is interesting because it was related to a model, the psychohistory, predicting the end of the empire, okay? With even the timing of this decay of the empire. So the emperor and the autocrats were not happy about that. So, and the book is on the transition, how to accelerate the transition from the present empire, which is obviously go to an end, and the future more balanced situation. So I suggest you to go back to psychohistory, because maybe we have AI now, generative AI, and we are able to predict, and then we must understand what to do with our prediction, okay? Especially in clinical application. We know the future, and we have to understand how to present that to the patient, and also how to deal that with the institutions. Thank you very much.
So thank you very much for this presentation, probably also with many questions, because I remember that our title is Quid est Homo. Now we can Quid est Robot, and to understand what is really now and the future robot. But please, we have some question. Please, Novarini.
Thank you very much for the talk. As a scientist, I'm very interested in understanding how you see, especially the part about education. So, and in the science, one of the things that I think is the most important is the positive error culture, right? So, to really foster the ability of making mistakes. And in fact, actually, I'm a neuroscientist, and in neuroscience, we know that the more mistakes you do at the beginning, the more difficult is the task, the more variable is the task, the better you learn. This could be with playing tennis or playing piano, whatever, right? So the more mistakes you do, the better you learn at the end, rather than always doing the same precise task and not having failure. So that you are much better, so broader in the variability of your behavior, if you want. So I'm just wondering, especially for the education, how we are going to implement that to be able to make sure that we are fostering this error culture, while instead, and we had a similar discussion yesterday about perfection, while instead going for perfection, which then will also decrease our capability of, in a way, adapting and behaving.
So I can say that I hope that you engage with education, because this is exactly the point that I fear. Because there are different culture. I don't say, in some countries, in some education system, there is a culture of monitoring, measuring, and assigning a score, and then the future of the pupil, of the subject, is constrained into a rail. You are in the first class, or you are in the And the Italian school was completely different. There was a positive error culture. And in the US, we are in the middle. So it's a cultural, but also it's something which can affect the future of our future generations. So the reason why I am supporting this idea or thinking on education is that I would like that more neuroscientists like you are engaging with this point and trying to present this, because the positive error culture is affecting us. For example, in startup, which is a completely different world, in startup creation in Europe, yesterday I was in a workshop on that. So if you fail, you are banned. It is exactly the contrary that you need. And so from learning how to make a task like playing piano or writing to developing a company, this culture is fundamental. So I hope that you engage in education.
I do.
Kevin and Hope. Kevin Fitzgerald and
Thank you, and thank you. That was a great presentation in terms of getting us to think about some of these things. So picking up on what you just said, in foundations, of course, the problem is the mule, right? The unpredicted element that doesn't follow the scope of their trace of history. Mm-hmm. How does then AI and robotics and all get built in such a way as to be open to what is essentially unpredictable, right? So you can't ultimately predict everything. So how do you build that in such, it's similar to the education problem. We are hardwired in a sense, through evolution to adapt to that. How does AI and robotics adapt to that?
To be honest, I don't know, but it's something that I would like to think about. So especially in education, because we don't want predictable citizens, okay? And this is the reason why when students or professors or colleagues are saying, okay, everything is done by AI and we don't have future, I think the place for university, at what we think about the European or North American, South American university is exactly that. We have a model where we have to think about unpredictability and creativity in the last sense, and also free will. So we don't want a world with everything is predictable. But I know from other countries, I don't want to say where, but I was also invited 15 years ago to a workshop with many neuroscientists from Europe and North America, and other countries and other scientists and from other countries to think about how to predict the abilities of children, okay? And how to make a better prediction. And it is exactly what we don't want to, okay? And also we want to give space for free will and also for the independent thinking, because this is the root of progress, okay? But I don't have the answer. We have to work on that. This is the reason why it's so important that university people and research people is getting together for preventing this evolution.
please, and yeah.
Hi, thank you so much for your talk. It was really inspiring. I had a question about when you were talking about the physical reasoning capabilities in robots and the language abilities of robots or of AI. I'm not sure that this is what you said, but you spoke a little bit about the types of representations or how computationally you solve those problems. In my work and in other people's work, we've looked at the underlying representations for solving these types of problems, and it seems like these are very distinct problems. And humans solve, a wide variety of things like language puzzles, math puzzles, and physical reasoning problems, every day. And we are embodied, like you said. But in AI, it seems like we have encapsulated systems that do different things really well, such as language in large language models and physical reasoning in some of these like hyper-skilled robots that you showed, and maybe even some of these more general humanoid robots. So how do you work on the engineering problem of putting that together? Is it possible, or do we need to have sort of a parts-based approach to simulating human intelligence? Sorry, it's a long
Oh,
question.
yeah, yeah. It's a very difficult question, but I can answer. Okay, first, I think that generative AI, so language models, are not really bio-inspired, okay? So are based on this scheme, conceptual scheme, mathematical representation of statistics and prediction. And so it's very difficult to strain this system and to have the same development to have and we see in the evolution of abilities, for example, in children, and how we develop manipulation ability. So it's completely different. We don't have to mix up, so I agree with you. Second, I think that this generative AI and language model is so powerful and demonstrated to be successful in language that the temptation today is to apply the same brutal approach, including, for example, touch sensing. Okay, so amplifying this system and going to touch sensing, because with touch sensing we can go forward in grasping, and then which is very difficult for robots today. So we have two problems: engaging with unknown objects, and also preventing fall of robots, because robots are falling down. And so to my knowledge, which is very limited, of course, is there are no approaches, bio-inspired approaches, studying how these evolve and grow in humans and trying to apply. No, we know that touch is fundamental, so we try to use this. And also because, and I finish because I know that I have not much time, but when we started more than 30 years ago, 40 years ago, we started with equation, okay? So robotics were used to have representation with matrices and forward modeling based on models of the joints and trying to understand the mechanics at the end and according to the input from the motor. So it was kinematics first and then dynamics, okay? So dealing with gravity. And so we were used to say that we apply equations, and then from equations we can describe the Newtonian interaction. Then this approach failed, basically. So it's not sufficient, because we don't have this possibility of calculating everything in the Newtonian space. So there were approaches based on neural network and machine learning, anticipating, and today I think this is in the same line of applying neural network for learning grasping that we and this was very successful for improving the hand capability. So we think that by introducing this in language model, we will improve, but it is not related to neuroscience, to my opinion, for the moment.
Please, another question.
I really love your approach of combining the 3 R's of research integrity, research ethics, and research security. However, in the current environment and moving to the future, how do we know that these 3 entities would not be hijacked by AI and evolution of this technology? I mean, at the moment, computationally and in terms of capacity, companies that run LLMs and AI advances are about 100 to 1,000-fold more powerful than universities or other organizations. These 3 entities require standards, values, and information. Clearly, they can completely flood the space of information. Clearly, they can shape values, our common values, what are acceptable values. And, standards are very easy to fall prey. I think it's a very easy target. I'm a pessimistic to think that, that all 3 entities, in a way, may be shaped by robots or by whoever controls robots with advanced AI.
This is a good point. I agree with you, but we have to fight, to be resilient and to resist and to try to be more, positive and also proactive. I think that there are companies working, for example, for understanding if a content online or a content in general was produced by AI. So If a post on Instagram is produced by AI, so it's important, but not so challenging for the life. But if a photograph or a picture in a paper, scientific paper, is produced by AI, this could be really affecting the application of drugs or similar. So when I think about research integrity, I am thinking about that. So making fake data and fake systems could affect the health of people. So we have to fight against that and to work on that because this could be really devastating for our world. And the only way we have is to try to make such kind of workshop like this and try to work together for developing responsibility in research for preventing that.
Thank you, Maria.
Thank you so much for your presentation. Allow me to address you just a very brief question. China is currently heavily investing in robotics for whatever use, without restrictions, let's say. United States is following as fast as possible. What can we at European Union do that is not trying to follow also the others? And you know that this is the main slogan today, competitiveness, and we are all competing for the same. And rules, norms, the 3 R's that you presented are understood by those that have financial, economic interests in robotics. They are understood as obstacles, barriers. I don't want to be pessimistic either, but what are we going to do knowing that China is really investing heavily in robotics? Thank you.
Yes. This is a very, of course, important point. I did not speak about China, but I know they are very competitive and they are also dumping the economy, buying robots for taking and putting their companies competitive. So it's not fair, the word. It's not similar to us. It's completely different word. And first of all, I think that there must be some more collaboration between Europe and China. So this idea of excluding Chinese from our world, I don't think could be successful in future. So science diplomacy is fundamental. So the first reaction is to try to restore science diplomacy. Okay, I know that we are weaker than them in that sense, but we must believe that some science diplomacy could be useful. Second, we must do better what we are doing, so investing more. So not taking money from research and putting into defense and military. Okay, so I said I am used to say when I am advisor European Union that taking money from research and putting this money and funding on military and defense is the most stupid thing that we can do, because defense of the future is research of today. Okay, so it does not make sense. Okay, it makes us even more vulnerable by doing that. And so we must improve our way of doing things, because I think it's also a cultural point on democracy, freedom, and I also believe that citizens, people in China, there will be some social problems also related to the adoption of robots. We know nothing about that, but there could be. So I am for resisting and doing something which is European, hopefully in collaboration also with Canada, US, UK, and restoring our multilateral world. And I will do all I can for supporting that. And not excluding continents like Africa or South or Central America, as we did before. We have to consider that there is large space and many people to engage in our game for freedom and for impact of science into the life. So, but if we exclude Africa, we exclude South America, Central America, we think that we can do all in Europe, the game is, I think, lost. So.
The last question.
Thank you, Maria Chiara. I was also an avid Asimov reader, and of course I have to bring up the 3 laws of robotics. Simple algorithm with some logical loops, so they were problematic. But my question is there anything similar that can be applied to embodied AI, like a simple algorithm, or is it way more complicated? And is there any update attempt, or are they still considered?
Okay. The 3 laws are free properties, okay? So, because robots, so this was a bit mistake from Isaac Asimov. So it's, we don't have a deduction system, deductive model that we have the equation of the law and then we try to solve with equation imposing the law in robots. Robots are inductive, so that means they are models of real engagement, and from that we try to understand the model of the world, even the model of robots. So the 3 laws are free properties that we must ensure for dealing with human beings and with the safety of human beings. So, and I think we learned from industrial robotics that before the law was to separate robots and human beings, because the 3 laws were not proved true, and it was dangerous for human beings to stay in the same environment. Today there is this collaborative robot area where we put together robots, and we have new rules, ISO rules, your international laws for establishing how a robot can share environment with human being. So it's in terms of engineering, it must be that you have to prove with experiments that safety is under a specific risk is guaranteed. But we have a field where we had a test bed of this, which is autonomous driving. Self-driving cars developed a framework for going from the principle to the practical application, with some drawbacks, some accidents. But I think the reason why Tesla is going to cobots is because Tesla developed this self-driving car model where we have the application of the 3 laws, free properties in practice, successful in some environments. So the 3 laws are guaranteed in some specific environments from the moment. This is the reason why we don't have a robot here. And the second application is related to the Roomba robot, okay? The Roomba is the vacuum, I don't remember in English, the vacuum, the vacuum cleaner in the house environment. This was the application of the 3 laws of robotics in our environment. But there were some cases where the robot, the Roomba robot, or the Chinese replication of the Roomba robot, where these robots were spying the household and taking pictures and information, and this was a violation of the 3 laws. So this is the point. And today we know that iRobot, the company selling millions of Roomba robots in the world, is failing. So it's closed because of the competition with Chinese market. So instead of speculating, I think in Europe, in Brussels, they should understand from this story how to support industrial system in Europe to be able to compete in that sense and not to close, not only for the 3 laws violated, but also because the production system in China is more competitive. So productivity is still a problem. So we have the 3 properties in some environment. In some case, we developed a framework like the self-driving car system or in the vacuum system. or in other environment like the surgical operating room, then we have the problem of productivity, which is still preventing us to be able to produce robots in competition with China.
We conclude this part of the discussion because we could go on during the coffee break, because it was, I think, very challenging how to understand the robots, and probably through the robots if we were able to understand better human being. So now we need to see what is the difference between robots and human beings, and quid est homo, that is our topics. Many thanks to Professor Carrozza.